This question is about the preparation of an ester. Ester F can be prepared from propantool and ethanoic acid. Give an equation for this reaction. Now, if you don't like skeletal formula, that's fine. We can try doing it in either type of formula. So I'm going to start with, I like the carboxylic acid to come first. So there's my carboxylic acid. The interesting thing about this is when we need to try and think about how we're going to put them together. When they come together, the O of the alcohol is going to do a nucleophilic attack on the carbon with the double bond O. We're going to eliminate water. It's a nucleophilic addition elimination type reaction. And then they're going to attach. Okay, so we've got our propantool, which is CH3, CHOH, CH3. Now you can use reversible arrows or not, because the esterification is reversible, but if you didn't do that, you wouldn't lose a mark. So we're joining, so we're losing this water and we're joining the oxygen of the alcohol, which has a CH, and then it has two CH3s coming off there, and we've got plus water. And we have to name that ester. So the main functional group the chain containing the functional group is here. So if I just do this in a slightly different colour, 1, 2. So it's an ethanoate from ethanoic acid. It's an ethanoate ester. Attached to that ethanoate, the longest chain is 1, 2. So it's an ethyl ethanoate. But we need to make sure we name that methyl group that is attached to the ethyl group that is attached to the ethanoate. And sometimes students are like, well, it's not in alphabetical order now. And the answer to that is it's not in alphabetical order because they're not, methyl and ethyl are not both substituents. The methyl is a substituent on the ethyl chain of ethyl ethanoate. This method is used to prepare the sample of ester F. Mix 10 centimetres cubed of propantool with 10 centimetres cubed of ethanoic acid. Add 5 drops of concentrated sulfuric acid, that's your catalyst. Reflux for 20 minutes. Transfer to a separating funnel, add sodium carbonate and shake. Transfer to a beaker and add 5 grams of anhydrous magnesium sulfate. Decant off the organic liquid and collect the ester using simple distillation. Describe how step 1, so we're only looking at step 1, should be done. In your description, you should give details of suitable equipment used to add each reagent to the reflux apparatus. Draw a labelled diagram of the apparatus used for refluxing and explain the safety precautions other than eye protection. So we've got 2 liquids that we're adding, and we're adding 10 centimetres cubed of each. This is not a quantitative test. So a measuring cylinder will be suitable for this. So I'm going to use a 10 centimetre cubed measuring cylinder to add, we have ethanoic acid, and propantool to the round bottom flask, or to the flask. Use a dropping pipette, because if you have a look, it just says add 5 drops. The concentrated sulfuric acid. Draw a labelled diagram of reflux. So using either a round bottom or a pear-shaped flask at the bottom, we're going to mount a condenser vertically. We need to try to avoid gaps, so I'm actually going to draw in one continuous line, a straight line for the condenser, and then into, so trying to draw into our flask, so round or pear-shaped. I've gone for round, and then back up the condenser. So there's no gaps there. Now we need to put the condenser jacket on, remembering that we need an opening at the bottom to let water in and an opening at the top to let water out. Does it say draw a label diagram? So this is our flask. This is our condenser. So our water's going in. Make sure you don't close the top of your condenser up here. Yeah, make sure it's open so that there's no pressure build up. Then we're going to get water out at the top. That ensures that the condenser fills with water, so we get efficient cooling. And we're going to then heat it up from the bottom. I'm going to put all the contents into the flask. The last thing it asked us to do was explain any safety precautions other than eye protection. So we're going to use a fume cupboard to avoid breathing in harmful organics and corrosive H2SO4. We're going to wear gloves as concentrated H2SO4 is corrosive. We're going to add anti-bumping granules to the flask. To reduce the size of bubbles. And we're going to use an electric heater or a water bath as organic compounds are flammable. In step 2, the reaction mixture from step 1 is taken and shaken with aqueous sodium carbonate. State the purpose of the sodium carbonate. Well, that's there to remove the acid catalyst, so to neutralise the acid, so any excess ethanoic acid and the sulfuric acid. State the precaution that should be taken. Well, we need to remove the bung. Let's just double check how they described it in there. It's a separating funnel, so they didn't describe their separating funnel exactly, so we could remove the bung or the stopper or open the tap on the separating funnel, but you'd have to be upside down to do that. We're trying to release the gas, not the liquid. Okay, why are we doing that? There'll be pressure build up as CO2 is produced from the neutralisation of the acid. Give a reason for the use of anhydrous magnesium sulfate. Well, that's our drying agent in organic preps. It removes water. And then it says, suggest how the purity of the ester can be confirmed during the distillation. We're going to check the melting point. Not the melting point, it's a liquid, the boiling point. Against the data book value.